Good afternoon, everyone. Welcome to this webinar of the Renewable Carbon Initiative. It is exactly 2, and today we have up to 1 hour, let's see how long it goes, on the latest publication of the Renewable Carbon Initiative, which is a report called Increased Methane Emissions in Crude Oil and Natural Gas Supply, with a deeper analysis and some implications for renewable carbon-based products. The majority of the webinar will be provided and held by Ángel Puente, who is an LCA expert and works at the Sustainability Department of Nova Institute. And myself, I will be moderating a bit the session discussion. I'm Christopher. I'm one of the 2 executive managers of the Renewable Carbon Initiative. Allow me for a quick and brief introduction on the RCI, just for those who are not part of the RCI as of yet. You see on this slide, the first slide of our membership overview, and on the left-hand side, you see the vision of RCI, which is the main point I want to highlight here, is that we are looking or trying to address the main cause of man-made, human-made climate change by facilitating the transition from fossil carbon to renewable carbon for all organic chemicals and materials. So we are specifically trying to focus on what we call embedded carbon, carbon that has been used as raw material to produce organic chemicals and all derived materials like plastics that come out of it. And all the members that are with us on board help us to drive and shape this attempt to transform the sector in the right direction. Here you see the second slide of members. So you have on the first slide quite a lot of what we call large suppliers, different producers in the chemical industry, from raw material providers to large chemical companies to specialty companies, etc. And the SMEs who are often tech providers. And then on the second hand, you also have brands to indicate that they're at the end of the value chain. Quite a lot of startups with interesting novel technologies, some supportive research institutes, and a growing list of partners who align with the goals of what we're trying to do. On the left-hand side, you see the 4 people that work or that formulate the RCI office, which is located at Nova Institute. And yeah, if that's of interest, you can find more information on the RCI at our website, renewable-carbon-initiative.com. And here on that page, you see our publication overview, and you find a couple of what we call key documents on the RCI, where you find a bit more on our main principles, on our key policy asks, a little bit more information, what does RCI offer members, in case you're interested to join, a flyer, and a glossary in regards to terminology. And you also find all of our publications. And here you see the latest publication, which is the mentioned report that Ángel will introduce to you in more detail in just a moment. But the idea of the report was born coming from a press release that we published in 2024, because we were aware of changes in lifecycle inventory database EcoInvent, which is one of the major lifecycle inventory / background databases for lifecycle assessment. And just here you see the changes in fossil feedstocks, so fossil-based naphtha, and in fossil-based PE, PP, and PET between the versions 3.8 and 3.10. I believe 3.8 was published end of 21 and 3.10 end of 23. And you just see that there's a significant increase in the carbon footprint of these fossil-based materials. And that was for us the starting point to say, hey, we would like to investigate that in further detail. And that spurred a new project and a report that was then mainly conducted by Ángel Puente. And with that, I would hand over to you, Ángel, and the next slides will be presented by you then. Thank you.
Perfect. So thank you, Christopher, and good afternoon, everyone. Yes, as Christopher said, so the idea is to highlight in this webinar some recent updates of LCA databases. We are mostly looking at EcoInvent, who for the first time uncover these significant underestimated methane emissions in the crude oil and the natural gas supply. But we are also gonna look at other databases, or was part of also of our analysis. Mainly, we will also discuss how new satellite data is showing that flaring processes in the crude oil industry and also leakages are contributed far more than expected and than previously reported. And this is, of course, having a significant impact on calculated carbon footprints, even on calculated carbon footprints before and these updates. And also coming from the Renewable Carbon Initiative, we also look at the implications for when comparing now petrochemicals in the LCA with alternative renewable carbon products. Okay, so first of all, we should talk about why these unintended methane emissions are so relevant. So what is methane? I believe you all here know all this, but it's good that we emphasize the why it's so relevant, methane, unintended methane emissions ending up in the atmosphere. So methane, as you know, has a global warming potential which is 30 times higher or more powerful than CO2 when we look at a time frame of over 100 years. But even more dramatically or significantly, 80 times more powerful greenhouse gas if we look at a shorter scale of, for example, 20 years. So that means that even if small quantities of methane are ending up in the atmosphere or was not reported before to be ending up in the atmosphere, that can significantly affect the environmental footprint of chemical products, petrochemicals. Um, on the other hand, we also must say that methane has a significantly lower, shorter atmospheric lifetime. So around 12 years, methane in the atmosphere is mostly broken down into other greenhouse gas emissions with a lower global warming potential than methane itself. In any case, the reduction of methane is crucial for the global efforts to limit the global warming potential of the Earth, and this is also clear with the goal to limit within 1.5 degrees to pre-industrial levels. When we look at sources of methane, it's clear also that enteric fermentation from yeah, animals, agriculture, landfilling, wastewater treatment are also sources of methane, but here the focus is on mostly on unintended industrial emissions by fugitive, venting, flaring, fracking activities in the crude oil and natural gas supply, and this is what we will discuss today. Next slide, please.
Yeah, I'll use the opportunity to just say one more word on questions. You can, of course, use in particular, please, the Q&A option here in the webinar to ask questions. We will try to address questions if they are very relevant for understanding. I'll post them while Ángel is going through the slides. Otherwise, I'll keep them for the end of the webinar and we go through the questions when Ángel is finished with the presentation. But just for everyone, please be aware you can, and you're of course invited to ask questions. And in case you're interested to receive the slides, we will send out an email with a link to the slides after the webinar in due time. Back to you, Ángel.
Yeah. Yeah, so what has changed in the world of LCA? Because of course, we are talking about unintended methane emissions and the effect on LCA assessments. I'm myself also an LCA practitioner, so I'm conducting daily on my daily basis on work at Nova. I'm conducting LCA of renewable materials, but as well we are comparing that with petrochemicals. And yeah, so we LCA practitioners, we normally rely on secondary upstream data from LCA data providers. It's not easy to have direct primary source for crude oil and natural gas supply data, or even for refinery processes. So we mostly rely, as you know, with with secondary data. And one of the databases that is most widely recognized and used is EcoInvent. It has yeah, a lot of scope of many products, high quality, very good documentation, and environmental data, and is one of the most used worldwide databases in LCA, and therefore is playing a crucial role in LCA, in many of the LCAs that companies are conducting, that institutes are conducting, also public entities are conducting. And what we observed in the press release that Christopher mentioned is that In recent versions, basically from EcoInvent 3.9 onwards, EcoInvent incorporated some updates accounting for these underestimated methane emissions, which was not included in the versions before 3.9. So for that, it's also important to understand who is supplying the data to EcoInvent, and the change that resulted in this finding is that until version 3.8 from EcoInvent, the methane emissions and the data for the natural gas and crude oil supply was mostly coming from the International Association of Oil and Gas Producers, and also data from British Petroleum, from BP. The change that happened is that from 3.9, which was released in 2022, EcoInvent now relied on data from the International Energy Agency, which used rather satellite data instead of the primary data directly supplied by the International Association of Oil and Gas Producers, and also data supplied by the World Bank, which, as you know, it also aims to promote a sustainable growth of the world. Next one. Yeah, so summarizing, there were some previously underestimated methane emissions in the crude oil and natural gas supplies that were not accounted, at least before EcoInvert version 3.9. And this is directly inflating the carbon footprint of petrochemical feedstocks, but also, of course, propagated throughout the value chain into many petrochemicals and daily polymers. And yeah, therefore we identify as the need to have an immediate action to address those emissions, to understand the origin of these emissions, and also to use the occasion to inform companies' policy about these findings, to try to promote also the transition to alternative sustainable solutions. And next one. Yeah, so therefore we decided to, or the RCI decided to do a study, an analysis study, with the goal to understand what was the origin of the underestimated methane emissions, also to try to understand or quantify what was the impact in the petrochemical feedstocks and in petrochemical products, and how this is also propagated throughout the value chain into the daily products that we use and in our materials. Also, one of the goals that we had was to investigate discrepancies among all the LCA data providers, because of course EcoInvent is one LCA data provider, but we also looked or tried to analyze what happened with other data providers. Are they also considering the same sources for the methane emissions, or are they incorporating these findings? So this is also something that we also looked at it. The study was commissioned by the Renewable Carbon Initiative, and yeah, it's a document of about 40 pages. It's free to download. You have there also the link, so you can go to the link and download the paper for free. And it's 40 pages. It's very easy to read. So I also encourage you to read and to spread also the word of this document after the webinar. Yeah, next one. Yeah, so more concretely, the goal that we had while doing this study was to analyze the recent changes in the crude oil and natural gas supply with respect to the underestimated methane and also associated CO2 emissions. Examine also how EcoInvent and also other LCA data providers are approaching this. And very importantly, also evaluate what is the implication of these changes when in the comparison of fossil-based chemicals with alternative renewable chemicals. This is also part of the assessment. Next one, please. Yeah. So then we are talking about underestimated methane emissions, and okay, where are these emissions coming from? So these emissions are particularly associated to crude oil and natural gas extraction, and mainly to activities known as flaring, venting, fugitive emissions, leaks, transportation. So this is the main source of these underestimated methane emissions. So if we talk about flaring or venting, venting and flaring both are common practices in the chemical industry. Is the intentional release or burning of natural gas, which is normally rich in methane, during the crude oil and the natural gas extraction. This is often done for safety concerns, for example, venting to avoid some overpressure in the system, or also for some economic inefficiencies. Also, flaring is a measure to reduce the global warming potential of the emissions, because if you burn, of course, the gas, most of the methane included in the gas will be released in the atmosphere in form of CO2 and not into the methane. So it's also a good practice in order to avoid further global warming potential. The problem or the challenge is that a typical gas flaring rate is at around an efficiency of 98%. So that means that 2% of the methane in the flare gas still will be emitted. And if we are talking about unintended, unmeasured extra emissions, and we know that the impact of methane is much higher than the one of CO2, even if only 2% of the gas that is emitted is in form of methane, it has a very significant effect in the global warming potential. Also, one of the challenges is that flaring so far is very difficult, or flaring rate efficiency is very difficult to. We don't have data from direct measurements from refineries. It's very complex to have such measurements. So all the data is mostly based on estimations and mostly done by satellite also measurements. Also, the World Bank is pointing that in many countries, even though the technology is there for flaring, flaring is not really happening, and with the implications that many additional natural gas is released directly as methane into the atmosphere and not oxidized into CO2. Other source of methane is fugitive leaks. This is unintentional. This is an intentional release of methane from piping, from worn seals, from failures, from accidents. So this is more unintended type of emissions, but these were also underestimated in the reports from the Industrial Oil and Gas Association. Next one. I think also it's important to understand where the data of EcoInvent for crude oil and natural gas is coming from. And in the new data from version 3.10, I have here in the figure the example, which was released in 2023, 2 years ago. EcoInvent increased the coverage of the geographical coverage to 41 countries, up to 27 from the previous version. So really increasing, they increase a lot the coverage of crude oil supply. And this is actually representing about 96% of the global production of petroleum in 2021. So it's a very good coverage that EcoInvent has for the crude oil production countries. But one of the challenges, and that's also important to understand, is that normally if you are LCA practitioners, you know that when you go you look into a data set, chemical production, for example, in Europe, and then you have some naphtha in Europe, And at this moment, it's very difficult to have traceability on where the for a specific naphtha the crude oil is coming from. And there are many also regional differences in the impact of crude oil depending on the regions. So basically what EcoInvent is doing, they are assuming a single average European refinery approach, because it's very difficult, of course, to model the complexity of imports, exports, etc., and the dynamics of crude oil market. But in reality, the landscape, of course, is very diverse, and we know that there are very variations in feedstock use and processing methods. So therefore, also in the future, and I think the trend is to have more and more granular data so that also one can identify regional differences depending on the source of crude oil. But I think that's important so that you also understand the limitations of aggregated data. In the next slide, actually you can see that very well reflected, because the first thing that we saw is that there were shocking data discrepancies if we look at different regions or countries in what we are talking today in this unintended methane emissions. For example, we observe 50% higher emissions in global oil production. This is the assessment from the International Energy Agency compared to the previous data provided by the International Oil and Gas Producers Association. But this is globally, at global level. But if we look, for example, only at specifically at crude oil coming from Saudi Arabia, we found that this value skyrocketed till 40 times more emissions. Or if we have another example, in this case, not for crude oil, but for natural gas supply from Russia or from Norway, also the World Bank indicated flaring emissions up to 3.8 times higher than previously reported by the international oil and gas producer industry. So we see that you see here how relevant is also this regional differentiation. And yeah, hopefully in the future also LCA libraries are able to also capture those differences. Next slide, please. Yeah, in the coming tables, what I have done, I've broken down with some relevant examples and this regional differentiation with more granularity, and I'm comparing always the old values. In this case, the ones provided by the international oil and gas producers with the new values provided by the International Energy Agency. And if you see here, this is for fugitive emissions. I already mentioned that globally, around 50 times more emissions are now reported compared to previous value, but this can also go up to 40 times higher, for example, in the example of Saudi Arabia. But remember the limitation when, for example, using databases like EcoInvent, probably it's very difficult to find a specific data set for Saudi Arabia, and rather we find a global or a European average mix because they are assuming a single average European refinery. In the next slide, I have the same example, but this is more concretely for venting and flaring activities. And you can also see here that the increase provided also by the World Bank, the data on increased methane emissions provided by the World Bank compared to the previous older data, in most of the countries is also around 4, 2, 1. There are even examples, like for example in the United States, where there is actually a decrease in venting and flaring, probably because higher flaring efficiencies. And globally, we can talk about around 1.5 higher emissions. So in that sense, you see that the fugitive emissions have are much significant, and venting and flaring still become very relevant, but the increase is less significant. Next slide, please. Also, very important to note is this new data was included and firstly integrated in EcoInvent in its version 3.9, so back in 2022. And this is where from coming from from 3.8 to 3.89, they included all this data we are talking about. But one of the limitations from EcoInvent is that despite knowing that for crude oil and natural gas supply, those data could not be propagated or be reflected in the carbon footprint of petrochemicals. Why? Because here we need to talk about the role of Plastics Europe. I'm talking about, of course, the example of how in Europe all these data sets for petrochemicals are calculated. Plastics Europe was delivering data for many petrochemicals, but at some point the data was a black box, and it was not difficult to break down the data into the naphtha, crude oil, and natural gas used. In other words, they provided aggregated data, and it was very difficult then for EcoInvent or CMA Pro to include all these known unintended emissions in the crude oil and natural gas supply, include that into many petrochemicals. However, and that's very significant, is in the version 3.10, so 2 years ago in 2023, EcoInvent included a significant methodological update, what they could achieve is to disaggregate all this Plastics Europe data with the support from Plastic Europe, and therefore they could introduce these unintended methane emissions also in the chemical sector. So that was propagated until all the petrochemicals derived from crude oil and natural gas. So now means that from version 3.10, and downstream petrochemicals also fully incorporate this update crude oil and natural gas supply data. And also for any of us LCA practitioners, working with disaggregated data sets is of course what allows transparency, and is also the only way to understand and to analyze or doing sensitivity or contribution analysis to understand where the impacts are coming from and how much is coming from the raw materials, in this case, crude oil, for example. And so that was a very, very significant update that EcoInvent did from version 3.10. Last year, the version 3.11 was released, and since then, and this year also 3.12 is currently released. And there are further methodological refinings or refinements, but the main and core data of the unintended methane emissions remain from the change that was done from 3.8 to 3.9. That brings me to some estimation of the impact, and here you have a chart in which I'm comparing. We are comparing the carbon footprint of different petrochemical feedstocks, naphtha, petroleum, butane, propane, in the different EcoInvent versions. And here you see that the change for petrochemical feedstocks, naphtha, petroleum, came already or happened already from version 3.8 to 3.9. Whereas then in versions afterwards, 10, 11, 12, the changes are due to other background processes and not to the unintended methane emissions. But you can see, for example, in the case of naphtha and petroleum, how relevant and how significant the increase in the carbon footprint due to the extra methane is. For example, for naphtha, we are talking about almost 200% higher carbon footprint compared to previously reported naphtha. Next one, please. And this is, of course, having a cascading effect on core petrochemicals in the moment naphtha has an increase in the carbon footprint, and here you have typical after cracking or some derivatives petrochemicals coming from naphtha and ethylene. So we observe a 34 increase in the carbon footprint. Propylene, something similar. Ethylene glycol, also very relevant, for example, for PET production, plus 35 carbon footprint, and even higher for other chemicals like butadiene with up to 64% increase. So this is illustrating how the changes in the upstream emission crude oil and natural gas directly also expands or increases the carbon footprint of downstream petrochemicals. In the next slide is basically a summary of what, is a more detailed analysis for olefins and derivatives. And we also included here for the comparison the data from carbon mines, which also have many data on chemicals. And yeah, we can see that in general around 30% increase in olefins and derivatives was observed. And there are two chemicals here that in which when we look at carbon mines, butane and butadiene, we see a striking also increase or difference compared to eco-invent. But this is due to other reasons. In the case of butadiene, is more related to an update of the data that Plastics Europe was using. The models that were used from Plastics Europe. So I'm not related to the extra methane emissions. And in the case also of the comparison of butane and butadiene in the carbon mine data sets, this is mainly coming from differences in the system boundary and the product definition. For example, eco-invent is assessing these products as mixed olefins, mix of butane, mix of butadiene, but carbon mine is focusing on pure 1-butene or 1,3-butadiene. And of course, all these purification steps, they add on top some layer of emissions, which are the result of this higher carbon footprint in the case of the carbon mines database. Next one, please. Same analysis for aromatics, also very relevant for example, gasoline, or in the case of paraxylene for PET production. And we also observed significant increases, a bit more moderated in the case of the olefins, but significant differences from previous versions. One also striking difference that we observed is in the case of phenol, when we observed that from version 3.10 to 3.11, the carbon footprint of phenol dramatically decreased. And this is also nothing to do with methane or upstream emissions. This is more to do with changes in the allocation method. Because in 3.10, if you know the production of phenol during it's called the Hock process, one produces at the same time phenol and acetone. And at that moment, acetone was considered a byproduct of the phenol production, but in 3.11, now acetone is also considered a co-product, and therefore through allocation in between phenol and acetone, the carbon footprint of phenol decreased from 3.10 to 3.11. So this is reflecting that when looking at different versions from different databases, different years, we only don't have to look only, of course, at the data, like for example, inventories, methane emissions, but also at any other methodological changes in allocation, etc., which also can have a significant role in carbon footprinting of products. Next slide, please. Yeah, if we move forward or downstream in the value chain, we can take the example of PET. And we observed, remember that for ethylene, we observe a 34% increase in the carbon footprint, and for PET, we are observing 25% increase. So, of course, the magnitude of the increase is diminishing along the value chain, but it's not disappearing. That's also very important. It's diminishing because there are other processes that farther down in the value chain don't require a natural gas or crude oil. But still, it is there. In this case, PET, as you know, is made of purified terephthalic acid, which had a dramatic increase, or originated from naphtha, which experienced a dramatic increase of 113% in the carbon footprint, and also ethylene glycol, MEG, which had a 34% increase in carbon footprint. In the figure on the right, you also see with more granularity as well that, for example, if we only consider the PTA, not MEG, MEG is included here in the polymerization part. And if we consider PTA production is the oxidation process, but if we consider that PTA is made out of paraxylene, so the pink part of the cake, but for paraxylene, around 25% of the impact is coming from crude oil or natural gas. The rest is coming from other processes in the cracking and refinery systems, which justifies that, for example, for naphtha, we see an increase of 100%, but up to PET, we only see an increase in the carbon footprint of 25%. Next slide, please. Yeah, and here we look at many polymers, and the most common polymers, petrochemical polymers, and in general we can say that around 20-30% higher carbon footprints were observed for most of the polymers. However, and that's also important to note, is that some plastics like ABS, polystyrene, PMMA, polyurethanes, polyamides like nylon still have not yet been updated. So still EcoInvent is working with Plastics Europe to try to disaggregate also those processes, those polymers, those production pathways until the naphtha crude oil level. And so far, these have not been propagated. And it's also important to understand that in the future, also those polymers will face an increase in the carbon footprint. Similarly, of course, PLA, which is also available in EcoInvent, provided by NatureWorks, didn't show any increase because of its bio-based origin, nothing to do with crude oil and natural gas. So now that we are talking about petrochemicals and all these results, it's important, of course, then what happens with the comparison with renewable alternatives. We look at 3 examples just to showcase also how this could affect the comparison of competing alternative renewable products. And we looked at the example of green PE, And now we observe that the carbon footprint advantage improved from 44% to 55%, so 10 points now compared to the fossil alternative. The same happens for renewables PP from Borealis, in which also 80% more favorable carbon footprint was now achieved in the comparison with fossil PP. And if we look at a monomer, for example, Indian glycols MEG, also from sugarcane, also a bio-based MEG version, 27% more favorable carbon footprint was also observed. Also important to note here is that this is just talking about production. If we include even the biogenic carbon uptake, which is part of another discussion, but savings or reductions of around 110, 200% are obtained in these examples when comparing with the fossil-based counterparts, which is very, very remarkable. Next slide, please. And I'm almost finishing. Yep, so we talk a lot about eco-invent, but we also look at discrepancies or potential discrepancies between or among different LCA data providers. Carbon mines, as you have seen, we also integrated that in the report, and you can check more carefully if you are interested in the report about results. But we also look at or try to look at Esfera and the eco profiles from Plastics Europe. And in the case of Esfera, we couldn't find, we don't have access to the data sets from Esfera, but we know that there are ongoing discussions between Esfera and IFOE. IFOE is also a German institution that also helps Esfera to translate the data from the petrochemical industry into LCA data sets. So there are ongoing discussions to clarify discrepancies or to potentially harmonize the approach with what EcoInvent did, which will also lead to further refinements in carbon footprint assessments. However, we don't have any further information about the current status. And Plastics Europe, they have also informed or announced that the eco profiles that they also these eco profiles are also publicly available on their website, have not yet been updated, and that they are waiting for a consensus among major LCA data providers on having robust and reliable oil and gas data sets. So still haven't updated any eco profiles. So with all this, and the next slide, please. We included some urgent actions in the report based on the results and on the assessment. One is that LCA databases should be updated regularly. Also, given the advancement the increase in the way the technologies to measure flaring or fugitive emissions are increasing, for example, with satellite data, more accurate satellite data. So we consider that an update of crude oil and natural gas data should be available at least every 2 to 3 years. Also, that new data should continue to be incorporated in order to also represent regional differentiation of crude oil and natural gas. And also future updates could also try to track the methane emissions from abandoned and closed oil and gas fields, which was not yet included in this assessment. Also, another recommendation is to improve the database comparability and to try to harmonize methodologies between the different LCA data providers, EcoInvent, Esfera, and Plastics Europe, which also speaks to the need for LCA practitioners to have transparent, disaggregated data and also comparable data among the different data providers. And of course, with the inclusion with this alternative LCAs to also expand or to foster the better comparisons between fossil-based and renewable carbon products, which will also support the transition towards renewables in the future. And in the next slide, I have also some few words from Michael Carros. You know, he's the executive manager of the RCI, and he's underscoring the significance of these findings. I'm just quoting. He's saying the fossilization of the chemical industry is more important for climate protection than previously thought. Politicians now have another reason to support the chemical industry's transition away from fossil carbon much more strongly. So therefore, addressing this methane in the fossil supply chain is not only needed for the global warming potential of the Earth, but also an opportunity to foster sustainable innovations. And with the next slide, I'm wrapping up some conclusions and outlook. So in general, in the webinar, we have highlighted and in the report how these recent updates in the life cycle inventories since the end of 2022 have uncovered significant underestimated methane emissions in crude oil and natural gas supply chains. This has led to the general significant increase in the carbon footprint of petrochemicals. And this also will lead in the future, and it's also happening right now, that many comparative LCAs have to be revised and recalculated again. Also, these findings highlight the importance of using up-to-date and also granular data that can reflect the specific regions. Improve assessments of venting and fugitive emissions should continue, as these remain a major sources of underreported emissions. And yeah, new data sources should continue to be incorporated to improve regional differentiation in crude oil and gas-related emissions. Although, of course, we know the challenge of these dynamic markets and geopolitical changes. All in all, also, it's very important that LCA practitioners have harmonized and data to work with, so that different LCA data providers are not delivering data which is very, very different, which makes the LCA very challenging. And with that, yeah, I'm done with the presentation, so I'm of course open for discussion. Also, as I said, you can download the paper for free on the RCI website, and yeah, I'm happy to hear some questions from you. Thank you very much.
Perfect, Ángel. Could listen for you for hours going on. Very, very good explanations, I think. We have a couple of questions in the Q&A. For everyone who's still here and willing to ask more questions, don't hesitate. You can also use the raise hand tool if you prefer and ask the question in person, but I'll start going through the couple of questions that we have. And Ángel, you might help us out answer this question. The first one is by Oliver. How are emissions from abandoned wells allocated to existing wells? Which logic is used here? I'm not sure if that question can be answered because he recommended here to include abandoned closed oil and gas fields, but it originally referred to, let me jump back to this slide here.
Yeah,
And
yeah. So abandoned wells is not part of the new methane data reported by the International Energy Agency. The International Energy Agency and the World Bank is only reported unintended emissions from venting and flaring, from fugitive leaks, and also from transportation of both crude oil and natural gas. The abandoned wells was not part of the new data, although we also encourage to try to include that in the near future.
I have a similar or another question on the same slide, maybe a bit provocative. Why were these four sources not considered in previous analysis? Was that intentional or were those parameters not identified?
Yes, so yeah, but, I think it's difficult to get transparent data, and of course, this is a part of the activities that EcoInvent is doing, and also EcoInvent at the same time is working together with other consultants to try to assess that data. But in general, transparency of crude oil and natural gas supply data is very transparent. So I think it was the reports from the International Association of Oil and Gas Producers were delivering data, but not transparent enough. And I think it's not until new technologies like satellite data having other type of measurements are identifying unintended emissions that now, yeah, they are reporting it. And then probably Ecoinvent together with their consultants, they reacted to the new reports and analysis.
Yeah, thank you. Okay, let's get to a bit to a higher level. There is a question on methane and biomethane and whether they are treated differently under LCA methodologies.
Methane and biomethane, if they are treated differently, so first of all, if we are talking about natural gas or methane from natural gas, it speaks of, or it's related to what we are discussing today, so natural gas supply. Biomethane will be, to my understanding, completely out of scope of this analysis, because we know that biomethane is rather coming from the composting facilities or biogas facilities from residual biomass waste. So it has nothing to do with this. If the question goes more into methodology or into other aspects, I don't see why they should be considered differently.
To the point. Thank you. There's the next question on changes in other impact categories. So is this research here that was, of course, focused on the carbon footprint? Do you see or are you aware of other impacts in different impact categories like water scarcity, like toxicity, or anything else?
No, so the focus of these updates were on climate change and greenhouse gases. But it's a very important and very relevant question. Of course, the more we expand to more impact categories, only the challenges for climate change. If we expand to other impact categories, the thing becomes more difficult into getting data. But no, getting this data is always complicated. We also have the discussion on how land use data, for example, is calculated for petrochemical wells. And that's also not difficult, and we don't have data apart from the data that the suppliers of crude oil, natural gas are providing.
Exactly. Okay. But the next question focus a bit on how stable are these changes in Econvent. The question is a bit on, with these changes visible in Econvent, do you think that going forward this stays stable for the next coming years, or can we expect further changes going forward?
I think with the introduction of these new satellite measurements, it should be more stable. Um, Hmm. And what we observe, of course, is with the years reduction, but more moderate in the carbon footprint of any chemical. But this is just because the whole background energy system is transitioning towards renewable. But from the feedstock part, yeah, there are many aspects, of course, here. One is if wells are being depleted and it's more difficult to extract, then the carbon footprint will increase. Yes, but at least these unintended methane emissions, I can only say that, of course, uh, only it has to be aligned with the technology, the technologies to measure those methane emissions on site. And so far, definitely seems to be more accurate to have satellite data than the data that the current producers are supplying.
I remember, let me follow up on this directly. I remember that when it was first came to light that there were unintended methane emissions, that it was also stated that in principle it is a rather quick and easy fix for fossil extractors to plug these methane emissions. But so there could be in a couple years an update because they fixed those unintended methane emissions and it goes back again. But that is, of course, uncertain how well that's going to happen, right?
Yeah.
Okay, I have two more questions, which are, I find them hard to understand, but let's try our best. The first one is that there's interest to understand what this has, what kind of effect that has on corporate carbon footprints. With a little bit the understanding, Svera has updated data sets for 2023, considering / including methane leakage. So if we make a comparison calculation for 2023 or going forward, what might be the impact or effect on corporate carbon footprints?
Yes, of course, corporate carbon footprint consider all the activities within a company facilities. And it's not only by the purchase of petrochemicals, for example, that you will see the effect directly there, but it's also in the corporate, you also have to report the impact of energy consumption in all the activities, and there also the role of natural gas in particular for heat processes, for also for electricity generation, also will be visible. As always, it's always a trade-off on how much in your corporate accounting are you relying on natural gas-based energy or on renewables, and how this is changing over the years. But definitely the effect will be visible in the same degree as for chemicals.
Thank you. And then the last question, I try to paraphrase. It's more a bit of a guesswork. Looking at Plastic Europe and the eco profiles, what would you estimate? How long will it take for LCA experts to reach consensus on how Plastics Europe should gather up-to-date data? Especially since the most recent data is more than 10 years old. Do you expect large changes when, if they do an update?
Yeah, I'm very optimistic about the role now of digitalization and artificial intelligence in LCA, so that any chemical process, any can be easily now transformed into numbers and real numbers every year. Because it is true, data from Plastics Europe or from in general from the chemical industry, it's very old. And it's also true that many of the processes are very established, and little changes are happening. The main changes are happening in the background energy system, but the rest of the process are very well established. But hopefully, with the new digitalization, also the new in the future, also product passport, in which every product will have to have also carbon footprint data. I think all these things, I hope they will accelerate also the way we get an transparent, accurate, and up-to-date data.
Perfect. Ángel, thank you so much. That was the last question. If there is no further raised hand or question, 2 minutes until 3, I would like to thank you, Ángel, very much for the very extensive explanation of the report. And I would like to thank you, all the participants, for staying until the end. We will follow up with the slides, at least for certain, next week. Thank you for the attention, and I wish you a nice afternoon and the rest of the week. Bye, everyone. Thank you.